Okay, so what we're going to do is we're going to do these in groups, okay? First of all, we're going to do the easy ones. Remember when we did the coordinates on a circle that's on the coordinate plane? Well, this is a circle on the coordinate plane. In fact, one of the exercises that I gave you on the worksheet included a circle whose radius is 1 and whose center is at 0, 0. So you should have already done what we're about to do right now. But now I'm going to explain why, okay? Well, first of all, if this is the point 0, 0 and the circle has a radius of 1, we know from here over to here is a distance of 1. So x is increasing by 1, but we're not going up or down. That makes this point always 1, 0. Okay? Now, if we go from the origin and go up 1, we have not changed our x, so our x is still 0, but we've gone up by 1 vertically. That's a 1 for y. So this point is 0, 1. This point over here, we're going backwards on x, so we're going to negative 1, but we haven't changed y, so it's negative 1, 0. And down here, we're not going to go left or right. We're staying right here in terms of x, but we are going to go down 1, so y is going to go down by 1, so y is going to be negative 1. So this point down here is 0, negative 1. Okay? All right, we're 25% done with the coordinates. Now what we're going to do is we're going to identify the coordinates at the 4s. Okay? Because to me, those are the easier ones. And here's what I want to remind you, is that pi over 4 is a 45-degree angle, right? And so, if I put in here a 45, 45, 90 triangle right here, and understand, we've already done this before. This is the second time we're doing this, but it's the first time we're doing it for the unit circle, okay? All right, so remember that well, here's what I need you to understand. I need you to understand that the x and the y are basically the legs of a triangle. Our hypotenuse is 1, right? Because the radius of this circle is 1. And the hypotenuse runs from here to here, right? And the x coordinate goes sideways, right? So x is the distance from here over to here, right? That makes the length of this leg x. And the height is going to be the y coordinate, right? Because that's what a coordinate is. A coordinate is basically just the distance sideways, comma, the distance up, right? So we're going to put the width of this triangle here and the height of this triangle here. Now here's what I want to remind you though, that this is a 45, 45, 90 triangle. Therefore, both of the legs are equal. And because both of the legs are equal, that means that the x coordinate and the y coordinate are going to be the same coordinate. So what we need is this, we need the leg length of a right triangle whose hypotenuse is 1. And we've done this before, but I'm going to do it again. So if we use a squared plus b squared equals c squared, the Pythagorean Theorem, c is equal to 1, and 1 squared is 1. So we're going to put a 1 in for c. Now we want to solve for a and b, or x and y, okay? But here's the thing, x and y are both equal, and that means a and b are both equal. So what we can do is we can now say a squared plus a squared equals 1, and a squared plus a squared is equal to 1 gives us 2a squared equals 1. Does this look familiar to you? Remember when we did the special right triangles, this is one of the special right triangles. Do you recall that the relationship between the legs and the hypotenuse is the square root of 2, right? And so what we're about to see is, the shortcut is I can say, hey, can't I just divide this 1 by the square root of 2 and get the x? Isn't this just 1 over the square root of 2? The answer is yes. Wouldn't that make this also 1 over the square root of 2? Yes. And the way we got that is, here we're going to divide by 2 on both sides, cancel. We get a squared is equal to 1 over 2, and now we do the square root of both. Square root of 1 is 1 over the square root of 2. Sure enough, 1 over the square root of 2. Here's the thing though. Remember that I told you that we're not going to leave an irrational denominator. So we're going to take 1 over the square root of 2 and we're going to rationalize the denominator. So we're going to multiply by the square root of 2 over the square root of 2. 1 times square root of 2 is square root of 2. Square root of 2 times square root of 2 is 2. And now this is our magical number, square root of 2 over 2. So the distance of x is square root of 2 over 2, and the distance of y is also square root of 2 over 2. And that means that the distance from here to here is square root of 2 over 2, and the distance from here to here is square root of 2 over 2, which makes the coordinates of that point square root of 2 over 2, comma, square root of 2 over 2. Okay? And so now we have the coordinates for pi over 4. Now here's the interesting thing. We can now use that to find the coordinates of 3 pi over 4 over here. If I were to put in this 45, 45, 90 right triangle here, well, this distance here, this is now x, not y. This is x and this is y. Well, it's square root of 2 over 2 and square root of 2 over 2. The difference is that we're now going backwards on the x-axis. So instead of going forward square root of 2 over 2, we're going to go backwards square root of 2 over 2. And so that means negative. So we're going to go negative square root of 2 over 2 and then positive square root of 2 over 2. So the coordinates are negative square root of 2 over 2, comma, square root of 2 over 2. Those are the coordinates of the 3 pi over 4 point. Okay? Now we're going to come down here to 5 pi over 4, and it's the exact same thing. It's square root of 2 over 2, but now we're going down square root of 2 over 2. So we're going to go to negative square root of 2 over 2 for x, and then down, and then negative square root of 2 over 2 for y. So the coordinates here are going to be negative square root of 2 over 2, comma, negative square root of 2 over 2. And now to get 7 pi over 4, to get to this point, we're going to go forward for x. That's a positive square root of 2 over 2. But then we're going to go down for y. That's a negative square root of 2 over 2. So this is square root of 2 over 2 positive, comma, negative square root of 2 over 2. And now we have the coordinates for all of the over 4 points. You can see that they're all square root of 2 over 2, x and y. The only thing that matters is whether it's positive or negative. Since we're in quadrant 1 here, we have a positive positive. Over here we're in quadrant 2, so we have a negative positive. Down here we're in quadrant 3, so we have negative negative. And over here in quadrant 4 we have a positive negative. You're going to see the exact same thing for these points as well. The coordinates here are going to be positive positive, positive positive. Here you're going to have negative positive, negative positive, negative negative, negative negative, positive negative, positive negative. Okay, because of the quadrant that these points are in. Now what we need to do is we need to try and identify what are the points, the coordinates for, now here's the cool thing. We just need to identify the coordinates for pi over 6 and pi over 3. And here's why. See this point over here at 5 pi over 6? It is relatively in the same place as pi over 6. It has the same height as pi over 6. And it has the same x value, only in the opposite direction. And therefore, all I have to do is take whatever coordinate is here, make the x negative, and I can put that over here. And then I can do the same thing down here for 7 pi over 6 and 11 pi over 6. Same thing for pi over 3 and 2 pi over 3. So really all we need to do is we need to find out what are the coordinates of this point at pi over 6 and what are the coordinates of this point at pi over 3. Well, to do that, we're going to use a 30, 60, 90 triangle. Okay? So let me grab a 30, 60, 90 triangle here. We'll use this one. And I'm going to put it in right here. Okay? There we go. And so this is a 30-degree angle, or a pi over 6 angle, a 30-degree angle. Pi over 6. Now, we know that the hypotenuse of this is 1, right? Okay? 1. And we know that in a 30, 60, 90 right triangle, here's the short leg. We know that the short leg is half of the hypotenuse. Well, half of 1 is 1/2, right? Okay? Well, that's the height. So that's the y coordinate, because the height from here to here is 1/2. So we know that the y coordinate is going to be 1/2. Well, that was easy. Now to find the long leg, do you recall that to go from the short leg to the long leg, you just multiply by the square root of 3. Okay? And so that makes this the square root of 3 over 2. Okay, because square root of 3 times 1/2 is square root of 3 over 2, and therefore the distance from here to here is square root of 3 over 2. And so square root of 3 over 2. So the x-coordinate, the distance from here to here on this 30, 60, 90 right triangle is square root of 3 over 2. That makes the x-coordinate of this point square root of 3 over 2, and the y-coordinate is 1/2 because the short leg of the 30, 60, 90 is 1/2. Now we can do the exact same thing for this point up here for pi over 3. We're going to take a 30, 60, 90 triangle. I have to use a different one because it's shaped differently, the direction that it goes. So I'm going to put it right here. Here we go. Yay. And now we've got, this is now the 60-degree angle, or the pi over 3 angle, which is why it's touching pi over 3 up here. We know that the hypotenuse of this right triangle is 1. Okay? We know that the short leg from here to here is half the hypotenuse. That means this leg is 1/2. That means that the x-coordinate, that's the sideways distance. The distance sideways is 1/2. So from here to here is 1/2. That's the x-coordinate, right? So we know that the x-coordinate is 1/2. Any guesses on what the y-coordinate is going to be? You guessed it if you guessed right. So here, this is the long leg of the 30, 60, 90 right triangle. And we know that the long leg from the short leg, you just multiply by square root of 3. So square root of 3 times 1/2 is square root of 3 over 2, making the height of this 30, 60, 90 right triangle square root of 3 over 2. That means that the y-coordinate of this point is also square root of 3 over 2. And so now we have our coordinates for pi over 3 and pi over 6. Now, isn't it cool, and isn't it going to be easier to memorize and easier to remember the fact that pi over 6 and pi over 3 have the same coordinates, only reversed? Okay? Now, there are plenty of ways to try and remember that the x-coordinate on pi over 6 is square root of 3 over 2, but I'm going to leave that to you. Okay, but you do need to remember it. Now, if I were to put that 30, 60, 90 right triangle over here at 5 pi over 6, look, my distance from here to here would be square root of 3 over 2, that's the x-coordinate, and my vertical distance would be 1/2, that's the y-coordinate. Except that I'm going backwards from the origin, so that's negative on the x, but I'm still positive on the y, and so therefore it's negative square root of 3 over 2, comma 1/2. Same thing up here at 2 pi over 3, only instead of coming back square root of 3 over 2, I'm coming back 1/2, and I'm going up square root of 3 over 2. So the coordinates here are negative 1/2, comma, square root of 3 over 2. Okay? X-coordinate, y-coordinate, right? Back and then up. Now down here, 7 pi over 6 is going to have the same coordinates as 5 pi over 6. Same coordinates as pi over 6, except they're both going to be negative because we're in the third quadrant down here. So we're going to have negative square root of 3 over 2, comma, negative 1/2. And 4 pi over 3 is going to have the exact same coordinates as 2 pi over 3, only they're both negative. So we're going to have negative 1/2, comma, negative square root of 3 over 2. 5 pi over 3 is going to be the same as 4 pi over 3 or the same as pi over 3, except that down here the x is positive and the y is negative. So we're going to have positive 1/2, comma, negative square root of 3 over 2. And then the 11 pi over 6 is going to have the same coordinates as pi over 6, only since we're down here in quadrant 4, it's going to be a positive and a negative. So it's going to be square root of 3 over 2, comma, negative 1/2. And this is the unit circle. 16 points, 16 radian angle measures. Well, technically 17 because 0 and 2 pi are the same, right? And then we have 16 pairs of coordinates, okay? 1, 0, square root of 3 over 2 and 1/2, square root of 2 over 2, square root of 2 over 2, etc. All the way around, we have the coordinates on this. Now, I'm going to show you how to use the tool, but all we have done so far is produce the unit circle. At this point, you need to be able to just take a piece of paper out, draw a circle, and produce a unit circle without looking at another unit circle. Now, the way that I did that when I was younger is I just, I don't know, I want to say for probably about 15 minutes or 20 minutes, maybe half an hour, I just did like 5 of them in a row until I successfully produced it without looking at another one. Okay? Then what I did is later that day, like 10 hours later, I did the exact same thing. Next morning, I did the exact same thing. That evening, the next evening, I did the exact same thing. There is no reason why in about accumulated maybe, I don't know, an hour to an hour and a half over a weekend that you should not be able to produce this unit circle from memory. And the reason you need to produce this from memory is because we're now going to move on to questions. We're going to move on to questions that ask you to identify the sine and the cosine and the tangent and the cotangent and the secant and the cosecant of these different angles. And the way you're going to get the information to answer those questions is from these coordinates on the unit circle. Okay? So what we're going to do right now is we're going to take a chance. We're going to try and produce a unit circle from memory. All right, here we are. Blank unit circle. You have one on your page. No notes nearby. Do the whole thing from memory. Don't even think, oh, is it this one or is it that one? Let me quick check over at my notes. No, you're not going to check over at your notes for any of this. As soon as you check your notes, you're done. Do everything you can remember, even if it's wrong, then check your notes or watch me do it, okay? You've got to do it without checking notes over and over until you can do the whole thing without checking, okay? All right, pause the video, go. All right, now you can check to see, and you can fast forward this if you want to, but I am going to talk it through, okay? I know that this is 0 and it's also 2 pi. I know this one over here is pi. This is halfway to pi, so that makes this pi over 2. This one is 1 and a half, so 3 pi over 2, or 1 half, 2 halves, 3 halves, so that's 3 pi over 2. Now I'm going to do just this section up here. I know this is pi over 2, this is pi over 3, this is pi over 4, right? 2, 3, 4. I don't have a 5. That's not one of my denominators, but 6 is. So 2, 3, 4, and 6, okay? Now what I'm going to do is I know that I'm going to go over here. This one's going to be an over 3, this one's going to be an over 4, and this one's going to be an over 6. This one down here is going to be an over 6, this one's going to be an over 4, and this one's going to be an over 3. This one here is going to be an over 3, this one's going to be an over 4, and this one's going to be an over 6, okay? All right, so I've got 1/3, 2/3 pi, or 2 pi over 3. So then this is 1/4, 2/4, 3/4 pi, okay? This is 1/6, 2/6, 3/6, 4/6, 5/6 pi, or 5 pi over 6. Or remember, we can subtract 1 from the denominator. 3 minus 1 is 2, 2 pi. 4 minus 1 is 3, 3 pi. 6 minus 1 is 5, 5 pi. Down here, I've got 5, 6, 6, 6. This is 7/6 pi, so 7 pi over 6. Or add 1 to the denominator. 6 plus 1 is 7, 7 pi. 4 plus 1 is 5, 5 pi over 4. 3 plus 1 is 4, 4 pi over 4. 2 plus 1 is 3, 3 pi over 2, right? This one also works over here. Remember, on this side, I double the denominator. 3 times 2 is 6, minus 1 is 5, so that makes this 5 pi over 3. Here, I can double the denominator. 2 times 2 is 4, minus 1 is 3, so it works here too. 4 times 2 is 8, minus 1 is 7, so this is 7 pi over 4. 6 times 2 is 12, minus 1 is 11 pi over 6. However you remember it. That's how I remember it. However you want to remember it, that's fine. You want to get it right, though, okay? All right. Now, I know that this point over here is 1, 0. I always do these 4 first because those are the ones that people forget. Do those first. This point up here is 0, 1. Backwards here is -1, but 0. Down here is 0 and -1, so 0, -1. Now I'm going to do this corner here. I'm going to do the coordinates up here. I know that at the 4, I've got square root of 2 over 2, comma, square root of 2 over 2, right? I can now take that over here, and because it's quadrant 2, it's going to be negative square root of 2 over 2, comma, square root of 2 over 2. I can take the same coordinates down here to 5 pi over 4. It's quadrant 3, so they're both going to be negative. So that's negative square root of 2 over 2, comma, negative square root of 2 over 2. And over here, at 7 pi over 4, it's the same thing, square root of 2 over 2, but the y is negative because I'm in quadrant 4, positive x, negative y. So negative square root of 2 over 2. Now I'm going to do the over 6s and the over 3s. Now, here's how I remember it. Square root of 3 over 2 is greater than 1/2. That is a larger number than that. This is 0.5. This is about 0.83 or something like that. This number is larger than this number, okay? And this point is farther this direction than this point is. This point only goes from here over to here. That's 1/2. But this point goes almost all the way to this point. So it has to be almost 1, right? Therefore, the x-coordinate here has to be 1/2. And the x-coordinate here has to be the other one, right? Which is square root of 3 over 2. Okay? Which means now the x-coordinate on this one becomes the y-coordinate on this one, and the x-coordinate on this one becomes the y-coordinate on this one. Okay? And now I have that corner. Now, there's another way I'm going to show you real quick before I finish this up. What I do here is this. Now, this is sort of crazy. Okay? In fact, actually, I'm going to show you after we're done. It's just sort of an advanced technique, I think. It's just a pattern that I noticed that I thought was kind of interesting. Okay? Now, because this is square root of 3 over 2 and 1/2, I can now bring that over to 5 pi over 6, only make the x-coordinate negative. So negative square root of 3 over 2 and 1/2. Down here, 7 pi over 6, now they're both negative. So that's negative square root of 3 over 2, comma, negative 1/2. Over here to 11 pi over 6, this time the x-coordinate is positive. So square root of 3 over 2, comma, negative 1/2, but the y-coordinate is negative. Now I'm going to do the exact same thing with the pi over 3. I'm going to bring these coordinates over to 2 pi over 3, but I'm going to make the x negative, so that's negative 1/2 and square root of 3 over 2. Down here, I'm going to bring it down to 4 pi over 3, but I'm going to make them both negative because it's the third quadrant, so that's negative 1/2, comma, negative square root of 3 over 2. And then we're going to come over to 5 pi over 3. Same exact coordinates, only we're going to make the y-coordinate negative because it's in the fourth quadrant. So 1/2, comma, negative square root of 3 over 2. And we have a complete unit circle with all of the radian angle measures and all of the coordinates written down, ready to use as our tool to be able to answer questions about trigonometry. All right, so now this is bonus, what I'm about to do, okay? This is just sort of a neat way of being able to identify all your coordinates. So I have coordinates here, I have coordinates here, I have coordinates here, I have coordinates here, and I have coordinates down here, right? Now here's the first thing you need to understand. All coordinates are over 2. Have you noticed we got square root of 2 over 2, square root of 3 over 2, and 1/2, which is 1 over 2. So a lot of these coordinates are over 2. So what we're going to do is we're going to make all of the coordinates over 2. We're going to do x and y over 2, 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 over 2. Everything is over 2. Now you might be saying, no wait, Mr. Ryan, this point over here, that is 1, 0. It's not a fraction. It's going to become a fraction. You'll see. Okay. Then what I'm going to do is, now it doesn't matter which direction you start. I'm going to start up here at the y. I'm going to start with the x's, and I'm going to go 0. Watch this. 0, 1, 2, 3, 4. Okay? 0, 1, 2, 3, 4. Then the same thing the other direction. 0, 1, 2, 3, 4. Got it? Now, every numerator is going to become a square root. Square root, 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 and square root. There we go. Now, last thing. A few things, just a little bit of cleanup. First of all, here, do you see the square root of 1 over 2? Well, the square root of 1 is just 1, right? So we can get rid of that. We can simplify that. Down here, same thing. Square root of 1 is 1. So we can simplify that, okay, because square root of 1 is 1. These are done now. We're done here. Now we just got to go to these. First of all, the square root of 0 is 0, and 0 divided by 2, guess what that equals? Well, that just equals 0. Square root of 4 is 2, and 2 divided by 2 equals 1. So we're just going to put a 1 in there. Same thing up here. Square root of 0 is 0. 0 divided by 2 is 0. And square root of 4 is 2. 2 divided by 2 is 1. And there we go. We now have all of our easy coordinates on the outside of the unit circle, which we can then mirror this direction, and this direction, and we're totally done. Okay? All right. Unit circle. You got to know this for what we're now moving on to is we're going to use the unit circle to try and identify the 6 trig ratios for these angles that are in the middle.